Good evening and welcome. Let me start this talk by people. People have needs for information, communication needs, and also social needs, such as the need to have other people feel that they get them. They achieve these goals using the most marvelous of human inventions, language. The Stanford psychologist Herb Clark, who's in the audience tonight, I'm not quite sure where actually, wrote, "The common misconception is that language use has primarily to do with words and what they mean. It doesn't. It has primarily to do with people and what they mean." For computers to communicate with us easily, to receive and give appropriate information, and for humans and computers to feel that they understand each other, computers also need the ability to understand human languages. Nowhere is this more true than for the powerful computers that we now have in our pockets. Cell phones. On these devices, reading is difficult, and input by poking at those virtual keys is really tedious. It's even harder for elderly people, for people who use Chinese characters, and for the many people in the world who have limited literacy. Thanks to amazing recent progress in speech recognition, computers now recognize the words of our languages with amazing accuracy. As a result of that, usage of speech on cell phones is taking off. However, computers usually still don't understand what people mean. That's true regardless of whether people are speaking or writing in a human language. Can I ask my computer to set an alarm for me? Yeah, I can do something simple like that. But can I ask a computer to tell me whether a restaurant has a vegetarian menu? No, that doesn't actually work. Can I ask it to do the kind of complex task that I could ask a human being, like booking my next vacation in Fiji? Not a chance of that happening. We need computers that can really understand human language. This goal of natural language understanding is now emerging as the central focus for many of the smartest minds and biggest companies in artificial intelligence. What will it take? There are really two problems. One is a language understanding problem, and the other is a knowledge of the world problem. They're related because knowledge can be found in texts. Early attempts to solve these problems began with human beings trying to write out dictionaries and rules of grammar for the computer. That didn't work well because human languages are too vast, too ambiguous, and too context-dependent. Here's one very quick example. The Pope's baby steps on gays. No, that's not what it's meant to mean. It's meant to mean the Pope's baby steps on gays. More recently, what has been working is letting computers learn about languages from a lot of text, some of it hand-annotated to show structure and meaning. Just as in vision, a powerful recent development has been the use of deep learning, neural networks for language. Starting from a large supply of text data, these networks learn distributed vector space representations of words which capture their meanings. Such models are really great for capturing word similarities and paraphrases. However, human communication is more than that. Humans compose complex meanings out of words and sentence structures via the principle of compositionality. And artificial intelligence is also going to require being able to understand bigger things out of smaller parts. We approach these tasks by doing analysis of language. Our open source Stanford Core NLP is one of the most used open source natural language processing packages. I'm going to touch now on 3 areas of natural language understanding that have been explored in my group. One is helping humans to communicate with each other. We've recently gotten some very impressive results from using deep learning for machine translation. Neural machine translation works by learning an end-to-end neural network which first reads a sentence and then generates word by word its translation. We've extended this approach with a novel model of attention. On a recent human evaluation, the resulting system had more than 25% less errors than the best previous generation statistical machine translation systems. An intelligent computer agent also has to understand how people feel about things. The widely used task of sentiment analysis determines whether someone is expressing positive, negative, or neutral views on a topic. In easy cases, you can just look for the positive or negative words. But language use is often more subtle than that, such as in the example at the bottom. With this cast and this subject matter, the movie should have been funnier and more entertaining. Many currently deployed systems simply match words that they find in the text. Here's what can go wrong if you do that. Huffington Post reported that the shares of Berkshire Hathaway go up every time Anne Hathaway appears in a successful movie. We've been working on tree-structured deep learning models of language that really understand sentences. Here the model can see that the first part of the sentence is negative while the second part of the sentence is positive, and put it together to understand that the positive part wins. Our final important goal is to allow computers to learn about the world and so to become generally intelligent. We're in a great new age where almost all the knowledge of the world is online. But it's online not as some kind of formal knowledge representation, but in human language texts such as Wikipedia. We've been working on the goal of machine reading. One way to test it is by asking the computer reading comprehension questions, just like you are subjected to in grade school. Our computer program learns to build process models from texts, which it can then use to correctly answer these questions. Within the history of life on Earth, human beings developed language really recently in terms of the kind of time frames that Fei-Fei talked about in her opening address. But nevertheless, that development of the power of communication very quickly set off the ascendancy of human beings over all other creatures on this planet. It was much, much more recently again that humans developed writing, allowing knowledge to be communicated across distances of time and space. In just a few thousand years, this took us from the Bronze Age to the smartphones that we have today. A key question for artificial intelligence and human-computer interaction is how to get computers to be able to understand the information conveyed in human languages. Fortunately, our AI systems now are able to benefit from a virtuous cycle. AI needs knowledge to understand language well, but it's also the case that the knowledge that our AI systems need is contained in human language, spread across the books and web pages of the world. Thank you.